Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 7 from the June 2023 International A-Level Edexcel Pure Mathematics P3 paper. And this question here is about exponentials. It says a scientist is studying two different populations of bacteria. The number of bacteria n in the first population is modeled by the equation n equals a times e to the power of kt, where t is greater than or equal to 0, where a and k are positive constants, and t is the time in hours from the start of the study. Okay, so t is the time from the start of the study. That's what t is defined as. So given that there were 2,500 bacteria in this population at the start of the study, so if t is the time from the start of the study, that means at the start of the study, t is going to be equal to 0, and the number of bacteria n is going to be 2,500. And there were 10,000 bacteria 8 hours later. That means when t equals 8, the number of bacteria was 10,000. Okay, that's what we can deduce from this information. Find the exact value of a, and the value of k to four significant figures. All right, so we have to keep those things in mind. Some people just read, up to here, find the value of a and the value of k. They don't bother to read, the details. So in the end, you might write k to 3SF because that's what the normal default is. But then you will lose a mark. If they specifically say write it to 4SF and you write it to 3SF, you will definitely lose a mark. So you have to be very cautious about, when you're reading the questions, read it properly. To take in all the information. Sometimes being in a rush will really cause more harm than good. All right, so now find the exact value of a and the value of k to four significant figures. So we know the equation, the model they gave us is n equals a times e to the power of k times t. All right, so that's the model they gave us. So we're going to use these pairs of values. So when t equals 0, n equals 2,500. So I'll use this first, and I will put this into this equation. So I've got 2,500 instead of n equals a, which we're trying to find, times e to the power of k, which we're trying to find as well, times t, which is 0. Now in this case, the k will be eliminated because k times 0 is 0, but it will leave us with what we're trying to find for at least one of the letters. So we have 2,500 equals a times 1, which is a. So that's it, a equals 2,500. So that's one of our answers. A equals 2,500. So that's one of our answers. Okay. And to find the value of k, we'll use the fact that when t equals 8, n equals 10,000. So now we have got the value of a, so we can put a bit more detail to this. This is going to be 2,500 because a is a constant, so it's going to be the same for every situation we have. K times t, so n is 10,000 this time, equals 2,500 times e to the power of k times 8. Okay, so now we have to solve this equation. So I'm going to solve it over here. So I'm going to take it up here. So I'll just put a little arrow so we know what was happening. So we got 10,000 is equal to, in fact, what I'll do first, I'll divide both sides by 2,500. So 10,000 divided by 10,000 divided by 2,500 is equal to e to the power of 8 times k. And that's going to give you 4. So 4 equals e to the power of 8k. If we want to now solve for k, it's trapped in the power of this number, which is e. So we've got to take the log to the base of the number to which it's trapped in. So we will take the log to the base of e, which is called ln. So we'll take the ln of this side and we'll take the ln of that side, which will give us 8k. Because the ln of e to the power of 8k leaves us with 8k times ln e, and ln e is equal to 1, so you're left with 8k. So therefore we can say k is equal to ln 4 over 8. Now, if the question said find the exact value of k, which it doesn't, that would be our final answer. All right, and we would get the marks for that. But this question says write k to four significant figures. So let me just write down what the value of k is first. We have ln 4 over 8. Something to my calculator. Right, so you have ln of 4 over 8. That gives us 0.173286. 0.173286, and goes on like that. So we want 4 significant figures. So the first significant figure is the first number after the first non-zero number, which is this 1. So you have 1, 2, 3, 4. So you end up with 0.1733. That's the value of k. So we found the value of a and k. All right, and that's the answer to part A. Okay, so the model would be, if you want to write it, we don't have to do this actually because it doesn't tell us to write the model, but I would write the model for further use as e to the power of, and I'll write it in this form. I'll say ln 4 over 8 times t. If we needed to use it in a further part of the question, I would use it in this more exact form. Okay, and we can then work out other things from that. So that might come in handy later on. But part B is about a different model. It says the number of bacteria N in the second population, because there was 2 populations. The first population is modeled with this model. The second population is modeled by the equation N equals 60,000 e to the power of negative 0.6 t, where t is greater than or equal to 0, where t is the time in hours from the start of the study. Find the rate of decrease of bacteria in this population exactly 5 hours from the start. So the phrase, the rate of decrease, the rate of change, basically, the rate of change with respect to time, exactly 5 hours. Okay, so basically this is telling you to differentiate this, find the NDT, the rate of change of the number of bacteria with respect to time. So they're asking us to find the NDT. So N equals 60,000 times e to the power of negative 0.6 times t. So we got to find we got to differentiate this with respect to t, and give us an expression which involves t for the gradient of this function, the rate of change. Now, how do we integrate? For example, if I have y equals e to the power of x, how do we differentiate such a thing? How do you find dy dx? Well, it stays the same. It doesn't change. So that's pretty easy. This will stay the same. You have 60,000 e to the power of negative 0.6 t. However, there's also a situation where you have a function inside the function. Like if you have y equals e to the power of, for example, 3x, and you want to find dy dx, it's going to be, stays the same, but then you multiply by the differential of what's inside the function. So you end up with 3 times e to the power of 3x. That's how you differentiate something which is e to the power of something. So this is what we're differentiating something which is e to the power of something. So the first step is it stays the same. Then you have to multiply it by the differential of what's inside the function. So you're going to multiply it by negative 0.6, because if you differentiate negative 0.6 t with respect to t, you get negative 0.6. Okay, so you end up with 60,000 multiplied by negative 0.6, which gives you negative 36,000. So this will be, the NDT is going to be negative 36,000 e to the power of negative 0.6 t. That is the NDT. Okay, now we want to find what the NDT is when t is equal to 5 hours. And we know that t is in terms of hours, okay, from the start of the study. So when t is equal to 5. So we want to find what is the value of the NDT when t is 5. Okay, when t equals 5. So we'll say when t equals 5, the NDT is equal to negative 36,000 e to the power of negative 0.6 times 5. So we're going to put this, we'll have negative 36,000 times e to the power of negative 0.6 times 5. And that gives us negative 1,792.334. So that's negative 1,792. Sorry, 792. 92.334. 0.334. It continues. So we need to find, okay, the NDT when t equals 5 is going to be to three significant figures now, which is what we normally would have to give the answer to. If the question didn't say anything, that's what we would do anyway. Okay, 3SF is going to stop here, so it's going to be negative 1,000. It says the rate of decrease. So we'll say, we don't have to put the negative sign. We can say therefore the rate of decrease, because the word decrease implies something's going down, okay, is 1,790, okay, and it's, you know, the number of bacteria, okay, per hour, okay, so 170 bacteria per hour. Okay, so you can just write 1,790. Because it says rate of decrease, you don't have to put a minus sign here. You can say the NDT is negative 1,790, that's fine. But if you write the rate of decrease is this, then that's what is more. It's just like acceleration and deceleration. When you say the deceleration is 5 meters per second squared, it means the acceleration is negative 5. Okay, so because they ask for the decrease, you write that. That means negative gradient. Okay, so there's the answer to part B. And now we're going to go on to part C. Now for part C, says when T equals capital T, when the time is equal to capital T, the number of bacteria in the two different populations was the same. So here I've got the equations written from the previous two questions, the first population and the second population. All right, so find the value of capital T given your answers to three significant figures. So we know that when T is equal to T, then the population of the first situation is equal to the same as the second population, right? So we can say that 2,500 times e to the power of ln 4 over 8 times capital T is equal to 60,000 times e to the power of negative 0.6 T. Okay, and what we can do here is we can divide both sides by 2,500. Okay, in which case this will be e to the power of ln 4 over 8 times capital T equals, and here you're going to have 60,000 divided by 2,500, which gives you 24. So that's 24. And I'm going to write this as e over 0.6 times t. And what we can do here is to get rid of the fraction, because this is, remember, a to the power of minus n is 1 over a to the power of n. Okay, so this becomes 24 when you divide by 2,500. So we've divided by 2,500 first. Now, when we want to solve an equation like this, a variable is here, t, we want to get rid of the denominator. So I'm going to multiply this side by e times e to the power of 0.6t, and also do the same thing on this side. Okay, these will cancel out, and you're left with here e to the power of 0.6t, okay, times e to the power of ln 4 over 8 t equals 24. Now, when you multiply two numbers in index form with the same base, a to the power of m times a to the power of n, you add the powers. So here we have the same base e, so we can add the powers. So this will be e to the power of 0.6t plus ln 4 over 8t, and that's equal to 24. Now, what we can do, this is like this whole thing is e to the power of all of this. So we can use the fact that we know that a to the power of b equals c can be rewritten. Okay, we can take basically the ln of both sides. Okay, if we take the ln of both sides, we're left with 0.6t plus ln 4 over 8 times t is equal to 24, is equal to, ln 24 is equal to the ln of 24. T is common in these two terms, so I have t times 0.6t plus ln 4 over 8 is equal to the ln of 24. So therefore t is equal to the ln of 24 divided by 0.6t plus ln 4 over 8. And that will give us our answer. So we're going to have ln of 24 divided by, what we're doing, 0.6 plus ln 4 over 8. Okay, and that should give us our answer. which is 4.10979. 4.10979. It continues on. Now, what do they specify here? Here they specified to give our answer to 3 significant figures. Through 3 significant figures. So we write our answer as t equals 4.11. So t equals 4.11 basically. Because there's the answer to 3SF123. And that completes this question. Question number 7 from the June 2023 Pure Mathematics P3 paper. Other questions from this paper can be found in the playlist that will appear in this region over here. Other questions from this topic of exponentials and logarithms can be found in the playlist that will appear over here. You can subscribe to my channel by clicking on this link, and you can find here a link to a video which tells you how to find the index documents of my channel, where you can easily go to or navigate through what you're looking for, saving you a lot of bother. Thank you for watching, and see you soon.